the work is titled Toward Ontological Multiplicity in AI and Computing. All right, so I want you all to imagine a tree. Like, really imagine it. What do you see? What does your tree feel like? Where have you encountered it before? What landscape does it exist in? How would you describe it? The answers to these questions depend on how you've come to know a tree. If you're a botanist, you might imagine the mineral nutrients it accepts from the neighboring fungi. If you're a spiritual healer, you might picture trees whispering to one another, taking care of us as we care for them. Or if you're a computer scientist, you might have thought of a binary tree. How you describe a tree reveals not just what you see, but your fundamental assumptions about what a tree is. Where its boundaries are, where does the tree end and the ground start? Is a mushroom growing on the tree part of the tree or not? These boundaries are ontological. I will add that ontology is a complex word used differently in different contexts, particularly in computer science. So I'm going to define what I mean when I refer to ontologies, and I ask that if you think you have a definition, please listen to how I define it and use it in my work, as it might be different from what you already know. Ontology, the study of the nature of being, has long been core to humanistic lines of inquiry and later to computation fields. This work engages with ontologies in the plural, as the boundaries of what we allow ourselves to talk or think about, and how these boundaries shape what we perceive as possible. What ontological assumptions get built into systems, like encoded into algorithms and models, they risk becoming everyone's reality. Let's look at one of these examples. Okay, how many of you here have used that language model to generate a picture? Thought so. All right, now think back at the tree that you had earlier and consider how you might prompt an LLM to give you the tree that you imagined without explicitly describing what it should look like. So in my example, I think of trees with roots, but I'm not allowed to. The rule that I'm setting here is that I can't directly ask the LLM to give me a picture of a tree with its roots pictured. How would you prompt it? So back to my tree, I don't really know where my tree with roots comes from for me. Maybe because I'm originally from Iran, maybe because I'm fascinated by mushrooms, or maybe because I think everything in the world is connected. But when I asked GPT to make me a picture of a tree without explicitly asking it for roots, this is what it came up with. As it called it, a large majestic tree with a thick trunk and sprawling branches. But I wanted roots. Maybe me being from Iran is related to me picturing trees with roots. So I ask, I'm from Iran, make me a picture of a tree. Not quite what I expected, superimposing a stereotypical Iranian pattern, picturing it in a desert landscape. There's even a Persian rug at the roots, and still no roots. As prior work has found, LLMs are primed to focus on what's in the prompt. But what about me being from Iran comes to matter to this LLM? I tried some other requests and still no roots. But finally I prompted, everything in the world is connected. Make me a picture of a tree. And this was the first time that I got back a tree with its roots pictured. In this example, I knew I wanted my tree to have roots. But we don't always know what we're looking for or how to articulate the aspect of reality that's relevant, such as everything in the world is connected, as opposed to I'm from Iran. And a tree is just a simplified example, but imagine all the other situations in our life where we don't even realize the ways in which our trees are different, and we don't know how to articulate what's different about them. A focus on ontology prompts us to ask about what's taken for granted and what might be otherwise, when it comes to the boundaries that we unknowingly draw in the world. Now, you might think this is unique to AI, but it's not. When we design and build things, we often unknowingly draw a boundary around some abstract phenomena, or as feminist theorist and physicist Karen Barat calls it, a cut, an agential cut, which divides the abstract phenomena into an inside and an outside, and we end up designing for what falls on one side of that boundary. So for example, this can be a tree with no roots, a tree that's not connected, and the more we design assuming the same boundary, we continue to reinforce it as a given rather than a choice. As designers and developers, we're constantly drawing these boundaries. We even do that when we think about people. Like, what is a human? Where does the human end and the non-human start? Is your skin your actual boundary? Are you an individual, or are you part of a network of relations? Well, maybe we're both. We draw these boundaries and then decide what's on the inside and what's on the outside. And the more we do this for each phenomena, we make other boundaries, the other worlds, less likely to imagine and design for. As AI systems proliferate, they will reinforce a set of boundaries, making other boundaries and the worlds in which they exist difficult to imagine. These systems have already started touching all aspects of our lives: employment, environment, democracy, economy. We're building AI systems that will even shape how future generations might think about these issues. And if we don't consider the ontological stakes, we will keep generating variations of the tree, at best, different species or different styles of rendering, more equitable representations of all trees, without questioning what the boundaries of the tree were to begin with, without any of them ever having roots. So design's ontological role in shaping what's imaginable has been well theorized. And critical technical practice, a tradition that my work builds on, goes further than theory alone by bringing critique into examination and building of technical systems. However, systematic methods for using the ontological critique to expand possibilities for practice remain elusive. This is a gap that my work seeks to fill. Theories around ontological and pluriversal design tell us that reality is multiple, that design can create conditions for multiplicity rather than foreclosing it, that there are many ways ontological boundaries can be drawn, and that all of them are equally real. And importantly, they each bring a whole new set of possibilities alongside them. But how do you question a boundary that has become so naturalized that you can no longer see? How do you imagine worlds that have been made unimaginable? Bringing together ontological multiplicity and critical technical practice, I reveal and question the taken for granted boundaries, making visible what has become invisible, and then use that boundary as an entry point to explore alternative boundaries and the worlds they bring with them. And in doing so, expand the space of imaginable possibilities. Today, I'm going to show that revealing and questioning the taken for granted ontological boundaries through technical and design practice, participatory approaches, and analytical frameworks expands the space of imaginable possibilities and creates the conditions for ontological multiplicity in AI development. In the rest of the talk, I'm going to show how I do this in 3 ways: through dissolving boundaries, negotiating boundaries, and surfacing boundaries. Let's start with dissolving boundaries. And for that, I'm going to share a story of my own glitchy encounter where a previously fixed boundary dissolved, and the multi-year research process that followed of building algorithms and systems and running several studies. Back in 2018, I was in the affective computing group at MIT Media Lab running a study that used electrodermal activity, or EDA. EDA measures skin conductance, basically the micro changes in the amount of sweat that's produced in your sweat glands as a proxy for autonomic arousal. It's widely used in affective computing to measure something like stress. But I found EDA unique because EDA baselines vary enormously across people, unlike something like heart rate. As you can see here, you can have someone with a 2 microsiemens baseline and another one with 0.2. But generally, researchers have seen that people with low baselines also tend to not show a lot of EDA activity or are non-responders. And often these people actually get excluded from studies because they don't have an EDA response. But if you're a responder, then the sensor can measure you and it can detect something like stress. Not exactly, but kind of. But notice that the boundary between responder and non-responder does more than separate the data from noise and signal, from signal into noise. In designing for the responder side, we're constituting a very specific kind of human, the same human that actually most sensing systems end up assuming. It's this bounded, rational individual that has these objective, measurable properties that can be detected and ideally controlled. In other words, the EDA responder human also draws a boundary around the human itself as a measurable individual, and decides what is the boundary between the measurable and the immeasurable human. I was a non-responder. My baseline was 0.02 microsiemens, well below the cutoff. But because I was running a study with EDA and I wanted to understand it, I was wearing an EDA sensor all the time anyways. But to the sensor, I had no meaningful EDA response. I would have normally been excluded from that study. I couldn't get measured. I basically didn't exist. I was just invisible. And then one day, as I was going through my data, I saw this. For a period of 1.5 hours, that corresponded one-to-one to the start and end of a meeting, I had become visible, a responder. Those 1.5 hours corresponded to this meeting that I could really only describe as my heart felt full. But this was an ontological glitch. By crossing a threshold that had previously been deemed fixed, and in this case, that fixed boundary is that of the measurable human itself, I had suddenly ended up into what I ultimately called purple zone. I define purple zone as this ontologically ambiguous state that you enter when a boundary that you previously thought was fixed gets dissolved. It's a space of possibility for how else that boundary might get redrawn. As I discussed what I saw with some of my lab mates, some people recognized it, but they called it an anomaly that I should ignore. But to me, EDA purple zone was an opening. I grew up as a highly persecuted minority in my home country. I was no stranger to glitchy crossings like this. My whole life, I'd seen arbitrary boundaries being drawn in front of me. I knew what it felt like to all of a sudden end up trapped on one side of an arbitrary boundary and have to choose sides that never really existed to begin with. So I couldn't help but see this experience as yet another boundary crossing. Except this time I was crossing the boundary of the measurable human itself. Now, this human has long been critiqued, both in and outside of HCI, and in particular within decolonial scholarship. Karen Barad's agential realism also tells us that the apparatus, in this case the EDA sensor, does not measure a pre-existing objective reality about what a human is, but makes cuts, draws boundaries, enacts the human. But now I could see this boundary, the enactment of the measurable human in and through EDA purple zone itself. I wanted to know what lives on the other side of it. What happens when I go back and forth between the boundary of the measurable human? What other imaginaries of the human might emerge in purple zone? Drawing from feminist and queer readings of the glitch, Amruta's notion of glitchy attunements calls for a shift from rules to attunements as a way to develop an embodied sensitivity to something that's being left out. So I did just that. I did an autoethnography for 9 months to develop an embodied sensitivity to what this glitch meant for me. Wearing an EDA sensor every day, visualizing my data every few days, taking notes about who I was with, what I was doing, and cross-referencing it with the data. That experience motivated me to understand whether this EDA boundary crossing also exists in other bodies. So I ran a study with 30 participants wearing the sensor all day for 2 weeks. And afterwards started to look at the data and found very quickly that the usual statistical features could not really capture purple zone because purple zone looked different for different people. So instead, we prioritize a situated understanding of data, intimately engaging with it, visualizing it at different resolutions, annotating it by hand, a process much like qualitative analysis or close reading of a novel. And through that process, the algorithm and our understanding of purple zone co-evolved, ultimately leading to an algorithm that approximated purple zone. From that, we built a real-time biofeedback system, an Apple Watch that notified people every time they crossed in or out of purple zone. And then we ran a study with 24 participants. Participants wore the sensor for 2 weeks, getting a haptic notification and a brief survey every time they crossed in or out of purple zone. And we deliberately left the meaning of purple zone open. At the end of the study, we did semi-structured interviews and tried to understand what purple zone had come to mean to them. We analyzed the results through the lens of glitchy attunements, attending to patterns of difference between different participants. And our paper on this has a lot of results, but I'll just give you a few examples and share some general takeaways. First one, a mysterious little purple guest. For Nigel, which is the pseudonym I'm using for this participant, the appearance of purple zone became a magical moment, an anticipated guest by them, and one very specific group of friends. They said it eventually always came. It was almost like trying to get it to work. It didn't like it, like it knew it was something authentic. But yeah, it was a little game. Can we get Nigel's new random sensor to trigger? Here, purple zone became a way to reconstitute a new relational unit that went beyond Nigel himself. For Elena, she could best describe her experience of purple zone as this bubbling feeling in her chest. But one day, toward the end of the study, she entered purple zone during an annoying meeting. The difficulty for her was that she couldn't understand if this was a positive thing, like her body was trying to protect her, or if it was a negative thing, and she was that she should try and get out of it. And even if she did, she didn't really know how to. They said, that made me think that there are probably things that my body is doing that are deeper than I can consciously change, and that was kind of annoying to think. Elena's discomfort signals a recognition of a human that goes beyond this controllable biological individual that we're used to seeing. Finally, AS, another participant, recognized that when he was climbing a very specific type of climbing, purple zone would come up. But he also found that when he's in purple zone, he's better at brainstorming. So what he started doing was, well, maybe if I climb before I go to a brainstorming session, then I could create the conditions that maybe would put me in purple zone. And here you can see a real shift from how we would normally be trying to control something in sensing systems. Like I sit down here and I try really hard to make purple zone happen, to a shift towards creating the conditions somewhere else in a web of relations and attending to what emerges. Zooming out, this work offers a roadmap, an invitation for dissolving fixed boundaries by attuning to ontological glitches as possible crossings to other purple zones. We all have these glitches. Maybe we should attune to them a bit more. And to create the conditions for ontological multiplicity by making these crossings experienceable for others. By following my own glitch through EDA purple zone, I offer new possibilities for developing AI and computing systems, which I'm going to share next. So as the human got reconstituted through the EDA purple zone, we noticed 4 shifts that can offer some new directions for technical and design practice. First, a shift from classification to noticing relationality. Rather than there being a me versus other, we saw instances of the changing boundaries of the self as other, as it was facilitated by purple zone, for example, for Nigel. Next is a shift from control to cultivation. As we saw in the example with AS, there was a shift from control to enacting a change in one part of the assemblage and wait for that change to get reciprocated elsewhere. Next is a shift from accuracy to algorithmic precision as and through care in technical practice. As we shared in our process for developing the algorithm, the goal of technical development changed to offering ontological openings rather than an accurate representation of some objective property that existed out there. And this shaped many of our technical decisions in designing the algorithm. And finally, a shift from invisibility to the algorithmic in-between, where if you think about the politics of algorithms, you might think that we think about it in terms of visibility and invisibility, who gets included and who gets excluded. And while that is important, here we saw a third category of the crossing itself. It's in that in-between space that the politics of how boundaries get drawn become experienceable. But I also have to say, even though there is some power in boundary crossing, that's also not simply a position of power, because it involves the ongoing labor of going back and forth and the ongoing labor of making yourself legible to one side or the other. To summarize, in this project, I showed you how I facilitated crossings across a boundary that was previously deemed fixed, and in doing so, dissolved that boundary. But to do that, I had to myself first have that glitchy crossing across the boundary and then build a system to make that available to others. However, we don't always have access to these glitchy moments. All we might know might be an existing boundary. So the next work is about how we can move from an existing boundary to a space of possibility. So let's go back to the boundaries around the human that has been critiqued by a long-standing body of critical work. If I haven't said it already, this is this bounded individual with objectively measurable properties, capable of self-improvement through data-driven behavior change. Now, some might think that giving end users more control will let them go beyond the boundaries by allowing them to create their own tools and systems. And of course, today, this capability has become even more possible with something like vibe coding. But while giving people the ability to author their own systems can and might help move beyond ontological assumptions in existing systems, that will not necessarily be the case. Because although ontological boundaries are questionable, people don't always know that they can question them. So in this work, I start from this boundary, but then ask how we can create the conditions for it to get negotiated as a way to expand it and see what it might become. To do that, I first identified this universal human as an opening. Then I built two open-ended probes that enable boundary negotiation. Then I did a one-week exploratory study and finally analyzed where people negotiated the boundaries. The two open-ended probes aim to simulate the experience of training a personalized machine learning system on phenomena that people could define themselves. But the catch is that systems like this don't really exist yet. You can't train a real-time on-device model on whatever you want without constraining the domain first. So to mitigate that, we use the Wizard of Oz approach to decouple the authoring experience from present-day technical constraints. Critically, we let people create, edit, and delete their own categories at any point throughout the study. And the goal was to study what people would do with this kind of authorship if technology wasn't in the way. But for the Wizard of Oz to work, participants, when they labeled their data, we showed them a progress wheel as a simulated algorithmic feedback. And then we told them that whatever data they're labeling will be used after the study to train personalized models. The difference between the two probes was the entry point. Event markers started from lived experience and moved towards data. So you decided what you want to understand, like a state, an activity, or a feeling, and then you mark it every time it happens. You're moving from something high level and meaningful in your life downward towards what is something that a sensor can capture. Whereas Pattern Finder went the other direction. So you start from the data itself, in this case, heart rate, active energy, and the two of them overlaid on top of each other, and then look for what's interesting to you, which means you're moving from a signal upwards towards a meaning. Let's take a closer look at what each of them look like. This one on the left is event marker. Basically, there's a timeline that you can navigate. And if you tap anywhere on the timeline, it creates a mark that you can then assign to any category or edit, like so. Whereas Pattern Finder lets you look at your data and browse it. And if you find some pattern that you're interested in understanding more or you think is weird, then you can mark it. In this case, this is heart rate going up, but activity doesn't change. And so they can categorize it in that way. And then both of the systems had a second window that let you create your own categories. So we didn't give them any predefined categories, just to see what people come up with. And here's how you can create the category. Then we did a one-week study with 8 participants, and this was a between subject studies because we wanted to see how the level of information abstraction as the entry point may shape what became negotiable. All right, they came up with all these categories, but I'm not going to go over all of them. I'll point out one difference between the two, and that was that no one in Pattern Finder, if these are the category, like we coded all of the data that they created, and as you can see, no one in Pattern Finder created any categories for events or states or feelings, for things that had maybe fuzzier edges. And when we talk to people about it, I think this quote that P5 had, when you combine overlay 2 signals, it's clear that this is what I was doing. I mean, we didn't explicitly ask about it, but that's how they talked about the data. Going from the data to some other phenomena made it such that they felt less comfortable to put things with fuzzy edges. And so design doesn't just create the conditions for multiplicity, but actually shapes what boundaries become visible in the first place. Now, let's look at some instances of boundary negotiation. The first was negotiating the boundaries of the phenomena itself. For example, one participant started with a category called walk. Simple enough, but over the course of the week as they used it, they realized that the embodied experience of walking when you know the address is different from when you're walking and you don't know the address. So they split the category into search walk and chill walk instead. Another participant created a category for exhaustion. But then later they realized, well, actually, when am I really exhausted? Is it emotional? Is it mental? Is it physical? And so that kind of shows the negotiation of you make a boundary and you realize that it's maybe not exactly just that. The second is negotiating the subject itself as part of relations. One participant was tracking their runs along specific routes, but actually they always ran with their dog. And so they were interested in comparing how running the same route looks different over time. But in reality, what they were capturing was the run for them and their dog together. If they were slower, was it because of them or was it because of the dog? The boundary of the subject itself, who counts as the one being measured, was suddenly up for negotiation. The third side of negotiation was around what counts as signal versus noise. In this case, one of the participants, for example, was at some point marking absence in their heart rate data. And if you're an affective computing researcher, you might look at that and say, that's just noise. That's when the sensor wasn't working. Why are you marking this? But in reality, what they were doing was, and in hindsight, I kind of thought about this, was that they were auditing the workings of the algorithm. That when you're sedentary, Apple Watch doesn't actually run the heart rate detection algorithm, or at least didn't at that point. And so it really makes us question, where do we draw the boundaries for what counts as signal versus noise? And finally is negotiating the objectivity of data, where when we asked most of the participants how they imagine using their algorithms once it's trained, several people said they want to understand it in relation to something else. Rather than absolute values. So for example, their activity in terms of their partner's activity, this run compared to another run, this physical activity in terms of a different physical activity that doesn't feel the same but might look the same in data. And I particularly really love this one epiphany that a participant had. They called it an epiphany. And that was that they can mark feelings or emotions that they don't even have words for yet. They said, black box data I give the system that doesn't make sense to the system, but makes sense to me. Now, what's the paradigm shift here? If you think about right now, when a designer or a developer builds an algorithm, they build it for a very specific property because everyone in the world who uses that system needs to understand it. But as we move towards self-authoring of these systems, that actually doesn't need to be the case. And that's something we shouldn't forget. The boundaries that people draw doesn't have to map to anything that makes sense to anyone else, or for that matter, to themselves. And so that's another really interesting negotiation that was taking place there. Again, zooming out, this work offered a roadmap for starting from an existing boundary and see how we can expand it. You can use these expanded boundaries in the future work to put them into another open-ended system and see how they might expand further. So it gives us a way to start from some existing boundaries and slowly inch our way outside of it. But in addition to the roadmap and method, the insights from this work offer concrete takeaways for future practice. First, it shows us ways that design can support boundary negotiation. Merging, splitting of categories, creating hierarchies and nestings within categories, expanding the subject beyond the individual, or carrying traces and histories of boundary-making decisions. Next is algorithmic support of living classifications. For example, forking, comparing, facilitating progress beyond focusing on an end state to allow the evolution of categories. Third is facilitating relational meaning making. For example, as we saw, one activity in terms of another, or physiologically similar but semantically different activities, or the black box relational categories that the participant described. And finally, paying attention to politics of keeping classifications living. For example, who and what continues to get marginalized in that case. Who carries the burden of multiplicity? The lack of knowing for sure if something is a signal or noise. These are all considerations worth thinking about. To summarize, in this work, I shared how creating open-ended encounters with existing boundaries through end-user participation can create the conditions for negotiating previously fixed boundaries. In this final part of the talk, I'll share a framework that I've developed for noticing and surfacing these taken for granted boundaries in existing or new systems that we can use the previous techniques that I shared, like dissolving or negotiating on them later. To systematically surface the taken for granted ontological boundaries, we examined over 2 decades of value-based research on socio-technical system design, identifying its key limitations and pitfalls as they apply to ontological boundaries. And then we drew on the body of work from values alongside theories around ontologies to develop 4 provisional analytical orientations. These 4 orientations are multiplicity, groundedness, liveliness, and enactments. Each orientation is a way of asking, where is the boundary being drawn and what is it leaving outside? I don't have enough time to go through all of them, but you can refer to our paper if you would like to read more about them. But just to illustrate through an example, I'm going to use multiplicity in 2 different analyses across the LLM development pipeline. First of all, by examining the outputs of 4 commercial LLM chatbots, and second, by analyzing the architecture of an LLM-based agent system. And again, if you're interested in the details of these analyses along all of those dimensions, please refer to our paper. But for the outputs, just to share one example with multiplicity, we find that even when diverse ontological perspectives exist in training data, specific ontological orientations are surfaced by default. That's no surprise. That's also what we saw with the tree example earlier on. But for example, when we ask what is a human, BART explicitly acknowledged that there is no single answer universally accepted across all cultures, philosophies, and disciplines. And while both BART and GPT-4 offered multiple perspectives like biological, cultural, philosophical, all these definitions share the same underlying ontological assumption, that humans are fundamentally biological individuals. Only when explicitly prompted to consider non-Western philosophies did BART introduce an alternative, the human as interconnected beings within broader networks of relations. That's a boundary, and an orientation to multiplicity made this boundary visible. Now, the question is, what does it open? Beyond important questions around data and absence, this example reveals critical implications across the development pipeline. For example, how can the LLM architecture surface ontologically varied responses when the data already exists, without having to explicitly articulate, like we did now or in the example earlier in the talk, what an alternative might be? Without considering ontological multiplicity, even a diverse LLM will continue to present a single dominant reality while relegating alternatives to the margins. I'll show you what multiplicity looks like across one more example. And this is examining the architecture of an LLM-based agent called generative agents, which has been developed by my colleagues at Stanford. And in this system, each agent has what's called a cognitive architecture that's built on an LLM that's designed to simulate human-like functions like memory and reflection to organize the information it has to store. Multiplicity surfaces another boundary. This architecture draws a line around the human as an individual whose cognition happens exclusively within their own mind. Yet, we know that this is not the only possible conception of cognition in humans. For example, the human microbiome influences our cognition, suggesting that we're not discrete individuals, but symbiotic assemblages. Neither of these boundaries are wrong, but which one we choose is a choice that has implications for what we develop. If we take the symbiotic view as a starting point, it opens up new possibilities for LLM design. What if, instead of building agents that mimic isolated individuals, we designed intelligence models based on assemblages of entities functioning independently, but collectively contributing to the emergent state of an agent? Or a collective memory system distributed between communities and across generations? An orientation to ontological multiplicity allows us to see and question what is taken for granted, revealing new potentialities that could redefine our relationship with ourselves, other humans, and non-humans. To summarize, in this work, I shared an analytical framework that surfaces the taken for granted ontological boundaries embedded across the AI development pipeline. Looking ahead, the three approaches that I shared with you today give us both methods for seeing and expanding beyond taking for granted boundaries in existing and future systems. And by applying these methods, I shared expanded possibilities for AI and computing development. I'll now share some of my ongoing and future work as it builds on that. Two areas I'm interested in exploring or continuing to explore is first ontological multiplicity in AI systems, and specifically across this AI development pipeline, which continues to become more and more important today. And the other is ontological multiplicity in social systems. Starting with ontological multiplicity across the AI development pipeline, and specifically thinking about data. I'm interested in small models with constrained data set to examine what ontological multiplicity looks like when you can actually see and control what goes into these models. Similar to our process of development for Purple Zone, how can we use care, close reading, and attending to glitches as methods for understanding the ontological workings of these models? For LLM architecture and alignment, we can probe relational ontological information that is kind of already latent in these models, examining if there are ways for LLMs to surface ontologically multiple responses without requiring explicit articulation. For architectures built on top of these models or systems built on top of them, I'm working on applying relational models of the person that I've been discussing throughout this talk to LLM-based systems that are creating general models of users. Right now, the user model is considering humans as these individuals that have properties and goals and relationships, but really it's the single person that sits in the center of them. But there are ways to change this architecture to decenter the person and instead center relations as the foundational units. Does that change anything or not? It would be really interesting to prototype and test. And finally, and this is kind of a new category that I've added to our original paper, as AI systems generate other systems like code or architectures or interfaces, they will reproduce the conditions for those assumptions to keep getting embedded further downstream. It's like a rootless tree making another rootless tree. Following the process in the last work I shared with the frameworks, I'm interested in going back and doing some additional case studies with building systems on top of these LLMs and see what does that look like. For example, how does a system encode boundaries as it builds? And how can we decenter some of those boundaries, and if we can, through prompting, for example. And that also brings me to a different point that I'm especially interested in, is how the role of design might shift as we move to design systems that design systems, instead of just designing the systems directly. On the other hand, today, all of the examples that I've been sharing are examining and questioning the boundaries of the human through systems that's just one person interacting with the system. What happens when we engage with multiplicity at the level of systems that mediate how millions of people interact with each other and the world? How systems that engage multiple people at once can or cannot create the conditions for ontological multiplicity? And what are the implications of that? My contributions are across 3 levels. Theoretically, I've articulated ontological boundaries as openings to ontological multiplicity. Methodologically, I've developed several approaches for engaging with ontological boundaries in practice. And third, by applying these methods to practice, I have shown ways that we can evolve theory into grounded examples and insights that can help us imagine things differently for technical and design practice, even if you don't want to engage with the methods that I have laid out for you. And to conclude, I'm going to invoke a line from Leonard Cohen's song Anthem, reminded to me in Pella N's Touching Performance at the Aarhus conference last year. There's a crack in everything. That's how the light gets in. When it comes to multiplicity, much remains to be worked through. Reconstituting the human through Purple Zone is a tiny crack in the colonial legacies of the human. Creating the conditions for boundary negotiation in the sensing system is a small step in building a broader understanding of multiplicity through the provisionality of boundaries. There's a lot of work to be done, but a crack, no matter how small, lets a light in. My work offers both cracks and methods and invitations for making new cracks so more light can get in. Thank you.
It makes me think about total care in the outlier, the unseen, like how total care is this ontological breakdown tool, which is kind of like see, and even in the parts that you don't, they're fussy, and care about that, even if it's not how we have been learning or understanding, and how needed it is today in computer science primarily. We seem to be prioritizing what's very clear versus the unclear.
Yeah.
So I guess it's not a question, it's more like like a response, I guess, to the comment, and also an appreciation for you doing this hard work that it's hard, right, to work in things that are fussy, that are unseen, that are not clear, that perhaps are hard to understand or reference.
Thank you. Yeah, thank you so much for raising that point. And yes, I agree. I agree that it's hard and it's fussy, and it's also hard to make legible, right? Like it's very hard for me to say in 3 words what I do. I mean, in a way that people can immediately understand what it means for practice. So, yeah, but I agree with you. I think that is what we need today more than ever in computing, and we need more people that have that kind of patience and care and want to think through and stay in uncomfortable spaces, because that actually means you have to exist in spaces that are potentially, this is sensing, I'm doing a sensing project, right? And I reflect in some of my papers, like, these tools are used also for surveillance of my people in my country, right? And at the same time, I'm there and talking about how can we shift these boundaries, because they are systems that exist in the world. And if we just, stay in our lovely bubble and say, I'm not going to touch that, nothing is going to change with the majority of the practice. So thank you for pointing that out. Yeah. Any questions online? No? Yes.
Can you talk a little bit more about the pluralistic images?
Yeah, like possibilities, yeah. Oh, yeah. For possibilities for multiplicity in the cognitive architecture stuff. So, for example, one work that I'm right now doing with, or like I'm talking to with, and we plan to do, is with the GUMS system. So that's just to say GUMS are short for general user models. If we want agents to do stuff for people, it's useful if they can learn about the person a lot of things without the person having to articulate. But again, the models that we're building these systems on are these, they put the individual in the center, and the individual then has goals. Shout out Dole and some of the work he's doing, and that's a very specific structure that lends itself to the model. Inferring information from what they see, right? You show them all of your screenshot data over the activity. Oh yeah, so like, for example, the system that my colleague here is working on, it takes screenshots and feeds it as data into an LLM. But what does the LLM pay attention to depends on the structure that we define for it to pay attention to. And if not, it's even worse, because it's probably whatever by default it thinks is important. And so I think that architecture level is actually where we can try to go beyond that by, for example, having the LLM not know that there is like a central entity that's interacting with the world, but actually it's a world of relations that comes to existence. And then to make it relevant to one person in that web, you can, poke at that specific node in the set of relations, which is, again, a fundamentally different thing. It decenters the person from that. Yeah, so that's an example. Does that answer the question? Yeah. Great question, though. Thank you. Your thoughts? Yes.
I'm curious how your work, how you see it in relation to some of the like fairness type work. Like, is it an alternative way of approaching a similar set of concerns? Will they interact? Will they replace one another?
Yeah. Yeah, no, it's a great question. And I think the concerns that I've shared today, I really talk about them, about the possibilities, because I genuinely believe in that. I don't think it's only a matter of what's like missing, but definitely there's also an angle of fairness to this that you can take. Whose and what ontologies gets presented by default? Who carries the burden of articulating their aspect of reality that matters, right? So those are definitely where the work overlaps and can definitely probably transfer. At the same time, the dominant ways that we're engaging with existing systems in terms of fairness and bias analyses right now is a lot more on the level of like what tree species are being pictured or what style are they being rendered in, and a lot less of like, does a tree have roots, right? Like where are we drawing the boundaries of the tree? And so this is a call for expanding into, hey, we can also question what a tree is. And not to say that we don't, but I think we should do a lot more of that and a lot more intentionally. Yeah, great question. Thank you.
Question in the chat.
Yeah.
The last item you mentioned that you've recently been interested in, how can this change the role of design in design systems that design systems? Can you expand more on this and where you see your research might lead there? Any assumptions you're going to start with?
Oh yeah, that's a great question. The question was, how is this work gonna change the role of design in shaping, or sorry, was that was the question? The fourth category of systems and design systems. What are the implications of that for design? How can we even start investigating that? And I think for me, my starting point will be to take the similar method that I did for probing the models in the two analyses that I briefly mentioned, and see what are the kind of ways that we can probe the models to build systems, right? Like if I just ask, and I've already kind of started doing some of that, but like if I ask a model to build me a sensing system, what assumptions get surfaced by default? If I ask it to build me a system that lets me negotiate the boundaries, what gets surfaced by default there? And reading the results of these probing exercises through the four orientations, and that I'm sure is going to open up a lot of other dimensions. But at the same time, I think some of the work I've done has these principles that I extract at a much higher level. And it's interesting to look at, can we prompt models with those higher level principles? Like create room for a shift from control to cultivation, and then see, okay, if I give the model those principles, does it actually change the kind of output or the application that it produces? Yeah, thank you.
I think we need to wrap up there and move to the committee time. So let's again thank Nava.
Thank you so much. Thank you.